how's it going?
I'm good.
So today I'll provide an update on the wastewater treatment and any key challenges and improvements that we have.
Okay, let's start with an overview of our current sewage treatment process.
Okay, so we follow the three-step process. Primary treatment, it removes the solids through settling, and then secondary treatments uses aeration, and then it breaks down organic waste matter with bacteria. Disinfection, typically with chlorine or UV, kills pathogens before the discharge.
Okay, what are the risks of untreated sewage discharge?
So it contaminates water with bacteria, nitrogen, and phosphorus, and that leads to disease, outbreaks, algal blooms, and ecosystem damage.
Okay, that sounds good. I mean bad. Okay, explain the importance of the aeration process in secondary treatment.
So the aeration increases oxygen levels. It also helps bacteria break down the organic waste efficiently, and without it, the treatment's incomplete, leading to some more pollution or odors.
And what contaminants remain after primary and secondary treatments?
Pharmaceuticals, heavy metals, microplastics persist. Advanced filtration or chemical treatments needed to remove them.
Okay, so walk me through our disinfection process. Are there areas for improvement?
Okay, so first we use chlorine or UV treatment, and then the chlorine's effective, but it also creates harmful byproducts. And the UV is safer, but it requires more energy to produce. Alternative methods like ozone treatment could be explored too. So that's a way of improving.
Okay, that's useful information. Should we be concerned about sanitary sewer overflows?
Yeah, so sanitary sewer overloads. They release untreated sewage into waterways, which increases the human health risks, and it causes heavy rain, blockages, and aging infrastructure.
Yeah, okay. And the safety team mentioned LD50. What's its significance?
So LD50 measures a substance's toxicity, and the lower the value, the more toxic. The higher value, the less toxic. And it helps assess the chemical risks in the wastewater.
And how do we use dose-responsive curves in risk assessments?
So they show how the doses, the different doses contaminate, the doses affect the health, and they help set safety limits and regulatory standards.
And are there wastewater-related public health concerns?
Yeah, so exposure to contaminated water can lead to diseases like chloria, hepatitis, and gastrointestinal infections.
And are there pollution-related diseases we should be aware of in our community?
Yeah, so waterborne diseases and respiratory illnesses, that they're linked to air pollution from the sewage treatments, and they can affect the public health.
Mm-hmm. So how might climate change affect our operations and local disease patterns?
So rising temperatures and extreme weather stress infrastructure, that increases the overflow risks, and it spreads the waterborne diseases that are public health risks.
Okay, that's useful information. And I've heard the term zoonotic diseases in the news. Is that relevant to our work?
Yeah, so wastewater can carry pathogens from the pathogens jump from the animals to the humans, and that increases the risk of the zoonotic diseases. And
Okay, yeah, thank you. And should we consider antibiotic resistance in our processes?
yeah, I think so, like 100%. Wastewater can spread antibiotic-resistant bacteria, and that requires advanced filtration and stricter monitoring.
Okay, thank you. And final question, is there another critical issue we should be addressing or concerned about?
Yeah, so I think we should invest in green infrastructure like wetlands and biofilters to naturally reduce contaminants and prevent runoff pollution.
Okay, thank you. That's understood. Let's discuss how we can implement these improvements moving forward.